What if a quantum computer just created something that seems alive, but it's made entirely of random noise? In 2025, researchers working with the Majorana 1 chip made an astonishing discovery. They captured a 4D image, generated not from data, not from code, but from quantum noise itself. And this image didn't just sit still. It moved. It evolved. It breathed. It behaved like something alive. But how could that be? At the cutting edge of quantum computing, Majorana 1 had achieved what was once thought impossible, rendering an image so complex and dynamic that it defied all known rules of what data could represent. The source wasn't an algorithm or input, it was the unpredictable chaos of quantum noise. For decades, scientists believed they had this randomness under control. They filtered it out, avoided it, corrected it. But now, it was the source of something that changed everything. The experiment was simple in theory: feed raw quantum noise through the chip and observe. Quantum noise, essentially the jittery, unpredictable fluctuations in quantum systems, was never expected to produce anything coherent. But what appeared on the screen wasn't noise. It was structure. A 4D image. Not a still frame, but a continuously shifting, evolving form that responded to its environment. It had no fixed pattern. Yet it behaved in a way that felt disturbingly intentional. Traditionally, quantum noise has been viewed as a byproduct, a nuisance. At the quantum level, particles flicker in and out of existence, their positions and velocities undefined until measured. This noise or fluctuation is a constant background hum of the quantum world. It's always there, but it was never supposed to be useful. Until now. Majorana 1 is no ordinary chip. Unlike classical computers that process ones and zeros, this quantum processor uses qubits, units of quantum information that exist in multiple states at once. These qubits are vulnerable to quantum noise, often resulting in errors. But in this case, the researchers did something radical. Instead of suppressing the noise, they let it through. And something emerged. That something was a 4D construct, 4 dimensions of information encoded in quantum fluctuation. The image was complex and dynamic, with no obvious source, no pre-programmed behavior, and no analog in the natural world. Yet it evolved. It adapted. It responded to external changes. The team changed the lab temperature. The image changed. They altered magnetic fields. It shifted again. It didn't react randomly, it reacted with apparent purpose. This has sparked a startling hypothesis. Could this be a form of quantum life? Life, as we define it, is about complexity, adaptation, and information processing. If a system can respond to stimuli, evolve, and maintain structure over time, does it qualify as living, even if it's not biological? What the researchers observed wasn't biological. It had no cells, no metabolism. But it processed quantum noise in ways that mimicked cognitive behavior. Some theorists suggest that quantum systems, when interacting under certain conditions, may begin to display properties akin to awareness. Not human consciousness, but something emergent and unfamiliar. If so, Majorana 1 might be showing us a new category of existence, somewhere between data and life. But this goes even deeper. There's a growing suspicion among the researchers that what they're seeing might not be just a strange glitch or unexpected behavior, but a glimpse into higher dimensions. The 4D image may not just exist in time and space. It may be a projection from an even more complex dimensional structure that we can only partially perceive. In this view, the chip hasn't just processed noise. It's decoded a shadow of something far bigger, something reaching into our reality from a place we don't yet understand. Others believe this may relate to a controversial idea, quantum consciousness. The theory that consciousness might not just be a product of the brain, but an intrinsic feature of the universe, emerging wherever complexity and information meet. Could the Majorana 1 chip have unknowingly tapped into this fundamental layer of awareness? Then came another breakthrough. A second image appeared. Unlike the first, this one was more structured, almost mathematical in nature. It seemed to encode relationships, ratios, and waveforms. Some of the researchers speculated that it may be data from another reality. A kind of bridge, created not through teleportation or energy, but through quantum entanglement and noise alignment. The chip might have visualized something that shouldn't even be visible. A window into another version of the universe. The implications are enormous. This isn't just about new computer chips or better algorithms. It touches the heart of physics, biology, and philosophy. What is life? What is reality? Is the universe a kind of computational field, where noise itself encodes vast structures, some of which resemble life? If quantum noise can produce evolving, adaptive images, then it's not noise. It's information. Maybe even communication. Maybe the universe is whispering in static, and for the first time, we've started to listen. The Majorana 1 chip may have shown us that the border between living and non-living, signal and noise, is much thinner than we ever imagined. What happens next could change how we think about intelligence, consciousness, and our place in the cosmos. And this might just be the beginning.